So if this is the Earth, and we put the origin of the Cartesian coordinate systems at the origin at the center of the Earth, and this one is called the geocentric. Okay, and also based upon our applications, we might have a top-centric. Okay, geocentric coordinate system we use in IJK as the unit vectors, and that is the symbol we use. And for top-centric coordinate systems, and top-centric, that means we locate the origin at the surface, on the surface of the Earth. So, for example, say here is our Fairbanks. Okay, at the GI, top of the GI, we have the radar site. So that is the reason why, and based upon the manipulation, the measurement or availability of the data, sometimes the data is simply available on whatever the coordinate system there, for example, the site of the radar. So here we have the top-centric, and top-centric coordinate system is this. Here we are using SEZ. So let me define what is SEZ. So from the center of the Earth, we take the line radial directions to whatever the city the radar site is here, and head up to our top of the head, and that is we define as the z directions, and which is unit vectors. Okay, and then also depends on the longitude. So here is the longitude of the say the Fairbanks. Okay, so S is defined by we tangent to the locations and we tangent to the longitude at the location. So here we're pointing south, so that is our S directions. So using S and using our right-hand rule, so basically we simply using our right-hand rule we swap in that direction by 90 degrees. In this way we define as the E. Okay, so in this way, it's easy. Naturally, that is forming Cartesian coordinate systems. Okay, so this is called the top-centric coordinate systems. And for these systems, here we have a lot of the exercise in the remaining sections. So here we have been playing around the reviewing about the coordinate systems is to get ourselves ready for this one. Okay, so let me continue to finish. So let me, we still on the sections of the reviewing the transformations of the coordinate system. And this should be the last one. So we have on the spherical coordinate systems. And last week, we done the first approach, and now I want to do the second approach, the second things. So here, let me draw this one. So again, this is IJK. I might have a different symbols, bear with me. So here, that is the spherical system. So this is a piece of the, so this is the equatorial plane, for example. And then here is one piece here. And So this is a point, and let me define so this is theta, and this is B. Okay, so this is the radial directions, and to here we align our IR, the unit vectors in the radial directions. Okay, so again, this direction simply is determined by you simply connect the origin of the ijk to the local point, and that forms the IR. And then I theta is in a way at this point, you tangent at this point to the latitude, assuming say here is the semi-sphere. At this point, you have the latitude line. Okay, so you simply tangent to that latitude line here. So that is I theta. Then I phi is at this point you tangent to this longitude line. So that is I phi. Okay, so again, locally, I theta, I phi, IR, they are unit vectors in individual directions. They are normal to each other. So for this case, we want to determine is what is the transformation matrix, assuming if we take the origin of this one aligned to here. Okay, so we don't consider translations. We only consider rotations. So what is the rotation matrix and between the two? So the sequence here we're performing is this. Okay, let me explain this to you. So basically the sequence of getting ijk to this local is this. We first rotate 3 axes about the k-axis by theta. Okay, so here you need a little bit imagination. So here we apply the transformation about the k-axis by theta. So right now the ijk is I come to here. Okay, and then the next one we apply the. Let me get this down. So we applied about the 3 axes and by theta. So here is, this is I, jk, and that is the unit vectors. Okay, so sorry, sometimes I forgot the overhead. So here we rotate this one by theta, and then we see what happens. So let me highlight this ij plane. So we rotate by theta. So which means this is corresponding. Okay, so let me give the notation. This is called the one axis, and this is called the. From here, can you see once we rotate in this way, these directions basically will be aligned to these directions. Okay, so here I label this one to here. Okay, so for this case, we can write it out in the transformations. So here from here is x, y, z. So x, y, z is in ij k coordinate systems, and to x will transform to 1, and then z will be transformed to theta, and then z will be the same thing. So we do this one, and then we look at it carefully. 1 will be, this one is theta here. So this is cosine theta, sine theta 0. This is minus sine theta, cosine theta 0, and 0, 0, 1. Okay, you simply take the projections of individuals. So this is sine theta, this is cosine theta. Simply have the 2 components here, etc. Okay. So once right now we align, at least right now this one is aligned to our goal Then the next step is to the next step is we rotate about this axis and in this way, and in the way we can have this K aligned to IZ. So here, let me write it up here. Step 2 is to rotate about the Q axis by that much. Let me see. I think I have a minor mistake here. So let me see here. So let me draw the green one. Okay, so right now this one is aligned to here, and one is here, and this one is still here. Okay, so right now I want to rotate is simply imagine I think I have a mistake here. I need to correct that. So if we rotate in this angle, say 90 degrees minus B, okay, so that means I rotate this one 90 degrees minus B. We see what happens. Never mind. I want to align is right now what I want to align is to rotate this one such that the one axis once rotated, let me highlight it. Okay, so after these rotations, and let me do this one here. So this is it's not good, right? Let me redo it. So right now this is 1 and this is K, and the outer plane, this one is our I theta. Okay, so right now what I want to do is to rotate this, and by the angle phi. So that means I1 will be rotating here, and K will be to here. Okay, so this is our new axis. And here need a little bit of imagination. Doing this way, basically these directions right now is aligned to here. Okay, and for this operation, we still keep this axis here. So one is moved to here. This is our IR. Okay, and so therefore this one is our IV here. Again, for these operations, we simply rotate the about this one is, again, need a little bit imagination. We rotate this one, then one axis will be kind of be sweeping up to that direction, try to align to this one. Okay, so under these situations, then we can have is this our transformation matrix, and in the old one is 1 theta z. Okay, so 1 theta z, and then compared to 1 is rotate to IR, so that is go to IR here, and theta keep the same thing, and phi right now is rotated from z. So right now this is the original z axis, and sorry, this one should be here. Okay, so let me keep this number. This is phi, and this is phi. Under these situations, then we can quickly write it up. So that is cosine phi. Okay, in terms of k, and this is sine phi 0, and 0, 1, 0, and this is minus sine phi 0 cosine phi. Okay. So here for this case, let me say this is the matrix defined as the R1, and this is the rotation matrix defined as the R2 here. So therefore, from these transformations, we have is R theta P will be equal to R2 times R1 times XYZ. Okay, or otherwise, XYZ will be equal to R1 transpose, R2 transpose, and R theta B. Will be good? Okay, with this one in mind, then we can continue on these sections here. So keep using these notations, and then here is a new section is rotations. Between IJK, geocentric coordinate systems. And it's easy, top-centric. So right now for this case we have is this. So for example, this is the local site on the surface of the Earth, and that is the real directions. So from here we can always know the longitude and altitude. So here this is our theta, and this is our the altitude, and that let me call it B here. Okay, so for example here the theta is altitude. Right. Is that right? Is this correct spelling? I always confused whenever you double check this spelling. So right now, for this case, we can exactly using these notations here. So from here, we need to look at one more thing here. So here, again, our rotation sequence is 3. And then followed by 2. Okay, so for this one, if we do everything and then again here we can we'll just do it. So rotate this by theta, and then we have is aligned to that direction. So right now rotate by theta. Theta is that. That is theta. Let me redo this again. So this is the Earth, and this is the equatorial plane. Okay, so here is the phalanx, and then here we draw the longitude to here. Okay, so here that is the fun. Oh goodness. Let me redo it again. Okay. I want to get a better drawing for this one. Sorry, I didn't prepare so well. So here is the Earth. So these are I-axis. Z-axis and K-axis. So basically, these are North Pole here. So say, for example, if say this is FAI here. Okay, so from here, this is the longitude, and then we do that one. Intersection is here. So this one is our theta. Okay, and this one is measured from our equatorial plane to here. That is our latitude. Okay. So I think the Fairbanks, the latitude is about 67 degrees. Okay, so now we align our corner systems. This is the Z and tangent to the south, and that is S, and then 90 degrees on the top surface, that is our E. So basically, this is the orthogonal. I think this viewpoint provided a little greater than that one. Okay. So from here, we do the transformations. Is I take care about this theta axis. So first one, I rotate about this theta. So in the IZ plane, we rotate to theta. So right now, this one you can see. If I rotate by theta, can you see these directions right now aligned to E? This one probably needs a little bit imagination, but that's supposed to be. Again, right now if you rotate this one by theta, at least I can align one axis, this one aligned to E direction. Okay, so here is our E direction. So we got this one down. Okay, so this is theta. So here from XYZ, in IJK coordinate systems, to again, this is one directions. I move to 1 and J to E directions, and then K is the same thing there. So that is cosine theta, sine theta 0 minus sine theta, cosine theta 0, 0, 0, 1. Okay, so now the next one is once I have the E aligned, then I simply is the next step is I simply rotate about this E axis in that direction, get the things downward by 90 degrees minus L. So in this way they rotate this axis after this kind of rotation. Again, this one is rotating in this way, and this axis will be aligned to S. Okay, so under this situation, the step 2 will be about the two axes and rotate by that much degrees. So that one is E, E, Z will come to as easy. Okay, after this rotation, this one axis by that one, under this rotation, this one axis will now align to S. Okay, E will be the same thing here. The third one naturally will go to Z. So this rotation will be cosine 90 degrees minus L, 0 minus sine 90 degrees minus L. 0, 1, 0, and sine 90 degrees minus L. 0 cosine 90 degrees minus L. Okay? So again, this one, let me call this is R1, and let me call this is R2, and give me one more minute and we'll be done. So therefore, S easy will be equal to R1, R2 R1, and times XY. Okay, so XYZ is the coordinate systems expressed in geocentric coordinate systems. SEZ is the coordinates of the coordinates expressed in SEZ coordinate systems. Okay, so under these notations, and I think this one. If you have time to read our textbook, this is notation defined as the D in our textbook. And we spend so much time on the reviewing of the coordinate systems, basically is to derive this quantity D. Okay, and that one I think is in our textbook 2.6.11. So again, for all the transformation of the coordinate systems is try to get this number. And this number is very important. Okay, and that one will be talking later on. We have an exercise about the data being transformed from the radar reading to the geocentric one. So we need to use this data. Okay. And sorry today a little bit messed up, and probably next time I will try to get a better view. Thank you.